Okay, going on page 50. After on the title here, write day 3 because we had day 1 and day 2. They all had the same title, so this is day 3. Alrighty, so we have this graph. It is labeled as the graph of F. It also goes on to tell us that the graph of F is shown. If it wasn't labeled, then we want to make sure that we label it so we know what we're looking at because we're going to use this graph for multiple functions. All right, so the first thing we want to do is find the domain and range of F, which is this graph. So you go ahead and write down the domain and range and interval notation of that graph. Should be a piece of cake. It is an Algebra 1 skill. Okay, so my domain is my set of all x's. My x's start at -5, go all the way to 5. Do I include them? Yes, I do. Range, I start at -3 and go to 3. Do I include them? Yes, I do. So there is my domain and range of F, right? Piece of cake. All right, so now it goes on to talk about g of x. Well, g of x is some sort of transformation of f of x. So we're going to be talking about g, but we have the graph of f, and I want to find the domain and range of g. The first thing I want to do is write my equations that define my new x and y values. So I want to look at each one of these transformations and ask myself, does it affect x or does it affect y? So does the 2 affect x or y? Y. So I'm going to underline it twice. The 1 affects what? X. And the 3? Y. So then I can write my little equations for my new x values. So my x for the g, all of my x's that go with function g, are going to be equal to, well, I'm going to take the x's from f, and I know it says -1, but what is that transformation? It's +1. We're moving to the right one, so that means that I take the x from the f function, and add 1. So you're not doing just exactly what that thing says over there. It comes from the words. If you need to write them down first, write them down first, right? That you're translating right one. Then I need to see my y values for g. That's equal to, well then for the y, because y doesn't lie, I'm just going to do exactly what it says. I'm going to double the y value from f, so 2 times the y values of f, and then we will add 3. There are little equations that can help us with everything. Okay? So my domain and range. I don't need to graph g to figure this stuff out. Okay? Because maybe sometimes we won't have the graph. Maybe they just tell us what the domain and range of f is and then give us this, and then we have to figure these things out. The domain, does that deal with x or y? X. So these are x values. For each x value, this is what happens. So my new domain, I take the -5, I add 1, gives me -4. I have 5, I add 1, gives me 6. And hopefully that makes sense because you're going from -5 to 5. Everything just moves to the right one, so the whole domain just gets shifted over. Okay, make sense? So then for the range, we basically do the same thing. I take that -3, I use this equation here, I double it and get -6, add 3 and get -3, and then 2 times 3 plus 3 is 9. It looks like the left end of the range or the bottom end of the range didn't change, which technically it didn't, because what we did is we took this, we stretched it, which made it go lower, then we shifted it up, and it just put the bottom right back where it was, but it's still a change of it. Okay, we all good with that? Okay, so now these are strictly x values, strictly y values, but now here's a point on f of x, and then I want to know what is that ordered pair going to be if it's g of x, and you're going to use these exact same little equations here. Find your new ordered pair. Bless you. Five, 7? You agree with that? Right? Just added 1 to the x value, and then my y value. Okay. So then I have g of 0. Am I going to use my little equations for g of 0, or what do I do for something like that? Just substitute it in, right? Substitute it in right here. So that will give me g of 0 is equal to 2 times f of 0 minus 1 plus 3. That means I have 2 times f of negative 1 plus 3. How do I figure out what f of negative 1 is? Look at the graph. So I'm going to go up to the graph. F of negative 1. What is f of negative 1? 3. Come back down here. And this gives me 2 times 3 plus 3, which is 9. Okay. What questions you got? Okay, so this one asks me for g of 0. This question asks how many solutions does the equation g of x equals 0 have? Those are two different things, right? This is when x equals 0. This is when y equals 0, right? So how many solutions does the equation y equals 0, g of x equals 0 have? Okay, so if I had a graph, f of x equals 0 right here, right? How many times does f of x equal 0? 3 times, right? But that's not what I'm being asked, right? I'm being asked for g. So I'm going to take g, the equation I have right there. So I know that g of x equals 2 times f of x minus 1 plus 3, right? All right, so that is what I want to set equal to 0. And then I'm going to solve for this right there. You with me? So that means I'm going to subtract 3 from both sides. So I'm going to get 2 times f of x minus 1. That's equal to negative 3. And that's being multiplied, so I'm going to divide, and I'm going to have f of x minus 1 equals negative 3 halves. Now, I cannot finish this by adding 1 to both sides, right? Do we all understand that? That's like trapped in there. Okay, so, but what this tells me is not when f of x equals negative 3 halves, it's when f of x minus 1. But that minus 1, all that does is shift it to the right, yes? Okay, so it doesn't affect the y value, it just affects the x. It's not asking me when does it. If I wanted to know when does g of x equal 0, then I would need to know exactly what the x value is. You with me? But nobody's asking me that. But when f of x is equal to negative 3 halves, somewhere along that line is when g of x is going to equal 0. So if I go up here, what's negative 3 halves as a decimal? 1.5. So negative 1.5 is right here. Okay, that's f of x. F of x minus 1 would just mean we just shifted over to actually be right there, right? But again, I don't care about the x value. I can't find that exactly right now anyway. But how many times does g of x equal 0? 1 time, because it intersects 1 time. So I can say then here that g of x equals 0 as exactly 1 solution. And then it says, explain your reasoning. Well, we explained it with algebra. To me, that's way easier than trying to explain anything in words, and I moved here, and I did this, and I did that, which all that stuff isn't going to make a whole lot of sense anyway. But sometimes your explanation is just your work. It's just you showing your work that you had to do. That's your explanation. It's totally fine. Okay? We okay with that? What questions y'all got? Y'all awake today? How'd I get the line? Well, I got f of x minus 1 equals negative 3 halves. So basically this is saying y is equal to negative 3 halves, right? So negative 3 halves is negative 1.5. So if y equals negative 1.5, that's a horizontal line right here. Okay? And so this is where it would be for f of x minus 1. I'd have to move it over if I wanted the actual x value, but nobody's asking me for that. We're just asking for how many times. Okay? Basically, we have to figure out that we're not looking for when f of x equals 0. It's when g of x equals 0, and we're down there. Okay? We okay with that? What questions you got? All right, good deal. All right, so then it says, on what intervals is g of x increasing? All right, well, I have f of x. I don't want to have to graph g of x, so I want to see when is g of x increasing. Can I figure out from my graph when f of x is increasing? When does f of x start increasing? -4, okay? -4 is right there, right? And then we increase until we get here, which is at -1, right? So I can say f of x is increasing on the intervals from -4 to -1, right? And then we start increasing again at 1 and go to 4. We agree with that? Okay, that's not what they're asking us for, but we need that, right? Okay, so sorry, I should have written that down here. So we're going to rewrite that. Or I guess you could draw an arrow if you don't want to, but f of x is increasing on, I have to look at this, -4 to -1 and 1 to 4. Not answering I didn't answer the question, right? But then I can do this. What do the 3 little dots mean? Therefore, g of x is increasing on, and then we got to figure that out. Now notice these are open intervals, right? Because for increasing, decreasing, and concave up, concave down, we just leave everything open. We let the people have their disagreements, but it's just going to be easier for you to know that you only have to worry about when you include it when we're talking about domain and range. And when we do sign charts and we're saying like when is it positive, negative, that's technically domain also, deciding if it's included or not. But for increasing, decreasing, concave up, concave down, just leave them open. Okay. All right, so g of x is increasing on. Well, when I wrote this stuff, when we talk about increasing, we're talking about y, right? The y values are increasing. But we wrote about what? X, okay? So this is all, this -4, the -1, the 1 and 4, those are all x values, right? So what do I do with my x values for f to get my x values of g? Add 1. So all I'm doing, since everything got shifted, I just add 1. This goes from -3 to 0, and then from 2 to 5. All right? Any questions at all? We good? All right, flip it over. So this repeated the graph because we couldn't see it. This is still the graph of f. The label did not transfer, so let's label that. My equation got a little bit into the graph, but it's fine. All right, so we have h of x now instead of g of x, and we need to find the domain and range of f. So, I'm sorry, of h. I'm not going to rewrite what it was for f. We can figure that out, but we need our equations for this, right? So my x's for h, got to figure out, and my y's for h. So I use -2, the negative and the 2 both affect y. The 3 affects x, and the 1 affects y. Right? So that means my x's for h, I'm going to take the x's for f and do what with them? +3 or -3? -3. Right? Because x is a liar, and we fix it with our equations. Algebra does not lie. X does in transformations. Y sub h, then I just do exactly what it looks like. -2 times the y's from f, and subtract 1. Okay? Everything revolves around this. Okay? You may think, well, I don't have to have that to do certain things, and you don't necessarily, but This will help you with literally all of it. And it's not that difficult to do so that you don't have to overthink things when you get into other things. Write them down. Learn to love them. All right, so my domain. I know that my domain starts for f. It starts at -5, which I include, but then I have to subtract 3, so that gives me -8. F ends at 5, but then I subtract 3 and I get 2. Right? My range starts at -3 for f, but for h I then double it, so -3 times -2 is 6, minus 1 is 5, right? And then 3 times -2 is -6, minus 1 is -7. All right, do y'all agree with those? What if I was to tell you something's not okay? What is not okay here? The order, exactly. Every time you write your intervals, you are going from least to greatest. For x, or for domain, it's left to right. For range, it's bottom to top, which is what we had and what we talked about. But because there was a reflection when we wrote it, it got backwards, right? Does this interval right here make any sense at all? It does not. There were some of you on this last test that still wrote stuff like that. I don't know what the heck what you were doing on some of these, but so we got the right numbers, but just by the nature of us just plugging it in as we talked about it, it didn't come out right. So we're just going to mark it out, and we're going to rewrite it, and it should go -7 to 5. Don't worry about erasing everything. No need to erase holes in your paper, right? Just mark it out and move on. Okay? You don't have to scribble it out either. It's fine to have wrong things on there as long as they're marked out. Everybody okay with that? So watch those things. Now, because that was an issue, that means we got to pay attention to the fact that we have a reflection in some of the other things that we do. Okay? So I have that A asks me on what intervals is the graph of H concave up? Well, the first thing I want to look at is where is F concave up, right? So, and when we talked about concavity, concave up is when your rate of change is increasing. Concave down is when your rate of change is decreasing, right? If we have a graph that we can look at that is actually curvy like this, then you can actually see that it's up and down, right? But where it changes from concave up to concave down, what's that point called? Point of inflection. Good. So a point of inflection is where we change from concave up to concave down and vice versa. Are we able to find exactly where those are? No. Okay. We do not have the skills for that. We are estimating that. Remember, when we're estimating it, we're just going to kind of ballpark it for whole numbers or maybe in halves. We don't have to get super perfect with that. If you're asked on an actual official test or something, it'll probably be labeled or you'll be told to use a whole number or something like that so you don't feel like you're guessing, right? But so right now we're going to not really guess, but we're going to kind of estimate things here. So it looks like here I'm starting at -5. I'm concave up until I get to probably right about there. That looks like a good point of inflection. And then concave down to probably right there. And then that looks good. I would say that kind of looks like where the concavity changes, right? So we're just doing it visually, which is kind of math cheating, but that's okay for right now. So concave up right here and right here. But here's the problem. We have a reflection. What are we reflecting in? X or Y, over the x-axis, right? So that means that this whole thing gets flipped upside down, right? So if I flip this upside down, what I have labeled in blue, is that still going to be concave up? No, it's going to be concave down, right? So if we want when when H is concave up, then we actually need when F is what? Concave down. Okay, so we're going to look at concave down for F. Like we labeled that, but that's fine because then this is really easy to do. Here's where we're concave down. Right? Everybody with me on that while we're having to do it that way? Okay. So we are going to write that F, I know it's asking about H, but F is concave. Okay, so this says we want up for H, but it's concave down, which is what we're looking for, on the intervals from -2 to 0 and 3 to 5? Okay. You agree with that? Say that again. This, that's decreasing, but it's concave up. So the function, the y values are decreasing, but the slopes are increasing. The rate of change is increasing. So concave up, it's going to literally look like a U up and down. I think you're supposed to be in 116. Okay, but I'm pretty sure it's probably there because he's the one that has that printer. Do you understand the difference? What you're asking me? Okay. Okay, so that's when F is concave down. So then we say, therefore, H is concave up on, do I use the exact same intervals? No, what do I have to do with these intervals? -3, right, for my little function up there. So -2 minus 3 is -5, then -3, right? And then 0 to 2. Everybody understand why we had to look at it that way? What's happening there? Okay, any questions? All right, so now we're going to look at increasing here. It says on what intervals is H increasing? So we're going to go back up here, and we're going to look for H, where H is increasing. We're going to look at when F is increasing. F is increasing from here to here, and then from here to here. Would you agree with that? Okay, when we reflect it, is it going to be increasing anymore? No, so since we reflect in the x-axis, we actually want to look at when F is decreasing, and F is decreasing from here to here, from here to here, and from here to here. Probably should use a different color there. Okay, that makes sense to you? Do you understand why we're looking at decreasing even though the question says increasing? I feel like y'all are not awake today. Let's go back over here. And I can say H is, not H, sorry, F is in decreasing. Oh, Lord have mercy. F is decreasing. That's what we have to look at first. On, it's decreasing from -5 to -4. From -1 to 1, and from 4 to 5. What do I do next? Therefore, therefore H is what? Increasing. Good. Good. All right, we all good with that? Any questions at all? Okie dokie. Now we have another one of these. Find any solutions to the equation h of x equals 5. So let's do that. H of x is equal to -2 times f of x minus 3. No, I'm sorry, x plus 3. Plus 3, and then minus 1. So I want to know, when does that equal 5? So I'm going to solve once again, right? So then I'm going to add 1 to both sides, so I get 2 times f of, what is wrong with my board? F of x plus 3 equals 6. Oh, thank you. board. Thank you very much. So then f of x plus 3 equals negative 3. Okay, we're good with that? All right, so f of x plus 3 equals negative 3. Let's go to negative 3 here. Right? How many times is that going to equal 30 something? I probably did. What did I do? Sorry. I did. Thank you very much. I'm on a roll here today. Something about those negative signs. Thank you. All right. F of x plus 3 equals negative 3, right? So here there is one time when I'm right here, right? Is that at negative 4, though? No. This equals this at negative 4, but that's f of x plus 3. How do I get my actual answer? Where do I have to go? If f of x plus 3 equals negative 3, this is a y value, right? You with me? So this negative 3 is a y value. I found that. It's right there. That goes with the x value that is negative 4. Yes? So that means that x plus 3 equals negative 4. So x value is negative 7. Because this doesn't say when f of x equals negative 3. It's when f of x plus 3. So if f of x equals negative 3 right here, I still have to move to the left 3 to get to that negative 7. That's what that one is. Okay. What questions do you have? Yes. So if I said f of x equals negative 3, which is not what I said, but if I said that, right, then that would mean that the y value is negative 3, the x value that goes with it is negative 4. You with me on that? So then I could say that if f of x equals negative 3, then x equals a negative 4. You with me from the graph? But what happened was we didn't have f of x. We have f of x plus 3. So instead of just putting the x there, I had to put the x plus 3, and then that takes into account that horizontal translation. Okay, does that help? We good? Any questions? All right, we're not going to do the last part.